If I do this talk live, I actually do a live demo in the middle of the talk. We actually have a noise source and go find it. One thing I just want to wave around while I'm on here is this is my little noise finding antenna. Back up where you can see it. Little handheld loop antenna. It's very simple. So it's a resonant loop. There's no power required. This has a little tuning knob here, and I'll show you the design for this a little bit later. If you saw the current issue of QST on the cover, is a guy with a noise finding loop for 80, 160 meters that barely fits in his car. This one effectively will do the same thing. It's not unidirectional, but this one works down to 80 meters, and you can hold in your hand, and you can build it basically for free. So this design, this is also in the ARRL antenna handbook, the current edition. So with that, I'll get the sharing going here. Find the right thing. There it is. Okay, can you see that? Slides up. And there we are. Okay. So down at the bottom is the link to my website. It's my old Illinois call, w9jps.com. And right at the top of my page, there's a link called RFI, which has this information and much more. So what we're going to talk about is types of noise and interference, typical noise sources, how to find the noise, how to mitigate it, what to do about it, and a brief discussion of what your rights are per the FCC, and then a bunch of references. Now, this is primarily devoted to fixing noise that arrives at your receiver, but many of the mitigation techniques also apply where your transmitter is causing some kind of interference, say with your neighbor's stereo. So, what are the types of noise interference? Well, there's natural, the case where natural isn't better. There's intentional and then unintentional emitters. So nature gives us this baseline of noise. You really can't really do much about it. You have lightning crackling away, and you have solar activity. If you point a sensitive antenna at the sun, you can actually hear the noise level pick up. There's a cosmic background. There's thermal noise. Everything that's above absolute zero generates noise. It's sort of called QRN, natural noise. You can't really do much about any of this. Some noise blankers work a little bit on lightning, but other than moving to a different location, this sort of sets your noise floor, that gentle hiss that's in the background on all bands. So then there's intentional emitters. Okay, this is other legal transmitters, things that are intending to generate signals of some kind. And one of the biggest issues here is a case of where strong signals may overload your receiver. Anyone who's been take your little HT up on top of Mount Diablo or something like that, where there's many high-power transmitters in close proximity, may well overload your receiver. Multiple signals, if there's multiple transmitters, they can mix. That's intermodulate. So they appear at frequencies you don't even expect. This a classic thing happens at field day. You get many transmitters on the air in a sort of an ad hoc configuration at field day, and you start interfering with one another. But the fact is, these are licensed. Okay, these are other licensed services. They're regulated by the FCC. These are, almost all, high quality stations, good equipment, things like that. They're not generating arbitrary garbage. They're just generating the signals they're supposed to. And that means we understand the signal. There's some legal leverage about who's interfering with whom and things like that. And more often than not, this is a case where, well, just get off the top of Mount Diablo and you'll be fine. Or if it's at field day, well, you'll have to do some things, and cooperate with one another and fix the problem. So here's the big problem. This is what we're really going to talk about today, is the unintentional emitters. So there's zillions of these things, and the problem gets worse every year. These are any electrical device that's not designed to be a transmitter, but may radiate RF energy at various frequencies. A lot of this really comes from the rise of switching power supplies. They started appearing in the 1990s, and now they're absolutely everywhere. Everything you have, if it's electrical or electronic, anything but an incandescent bulb and a heater, you plug it in, turn it on, it's probably going to generate some noise because of a switching supply inside. But everything on this slide here is something that I personally have been involved with in terms of mitigation. So, you name it, arc welding and bad street lights and all kinds of things. So all these different things, we'll talk about these, how to find them and what to do about it. So there are some tools and techniques we can use to help locate these sources of interference. There's spectral fingerprinting. That's where you try to understand what the signal is. You go around, turn things off until it goes away. Once you've turned it off, say, aha, it's on this circuit. There's radio direction finding, where you don't really know where it is. And there's one little nitpicky thing called ultrasonic detection, specifically for open arcing. We're not really going to talk about that. That one is used if there's actually arcing up on a power pole, something like that, and it generates an ultrasonic signature. So, fingerprints. So the first thing is, I have noise. Well, tell me about it. What do you hear? So you tune around. What frequencies is it on? Is it every 50 kilohertz? Which bands is it on? Is the signal periodic? In time, does it like pulse or something like that? What times of day or night is it on? Is it on just for a while? Is it on repeatedly? Things like that. Listen to it. What does it sound like? Does it sound like just 60 hertz buzz? That's the old, you take a microphone input and hold your finger on it and you hear that loud buzz. A lot of things generate that kind of noise. Does it sound like video? Many of you probably heard what video sounds like. The pattern changes with the scene, in which case it's related to some television transmission. Maybe it's pulses. Do you hear voice? If there's voice there, well, it's some other, like AM broadcast. That gets into equipment if you live near AM broadcast equipment. Record the audio. Ask other people for identification. ARRL has a lot of good RFI pages. They actually have one called Sounds of RFI. And they have a long list of things there. They show you these little pictures here on the screen are things like what you'd see on an oscilloscope if you looked at the sound, different kinds of devices, and they actually play the sounds of these things. So, getting that kind of information may help give you a clue as to what it is, but also if you write all this down, when you go to mitigate, when you go to solve the problem, you want to verify, is this my problem that I solved? Have I found this one, or is it something else that I've managed to change? So keep a log of these kinds of things. Now, if you have a software-defined radio, so a modern radio has a panfall display that is effectively a spectrum analyzer. That's extremely useful, because with this you can measure, the amplitude and frequency of these signals, track dynamic signals, things that are moving. Maybe they're moving in frequency. You hear them, drifting up and down the band. Signals that appear in multiple locations, say, like in this case on the screen, every 100 kilohertz. This was a battery tender, one of these little low-power battery chargers under the hood of someone's car, and that made quite a racket. The solution to this one, by the way, was to buy the neighbor a new battery tender, and that took care of that. Just had to find one that was quiet. But with a screenshot like this, you can very clearly compare before and after mitigation what happened. And also this helps other people who may be knowledgeable to help identify what they think your problem might be based on some experience. So to find these things, the first thing to do is start turning stuff off. So start with your own house. More often than not, the problem is in your own house because that's the closest thing to your antennas. If something isn't close to your antennas, it's not likely to interfere. So start unplugging things, or even better, turn off circuit breakers. See when the noise disappears. If you can run your radio, your receiver on a battery, you can turn your whole house off, and then absolutely for certain the house is not the problem. Oh, if you have an UPS, an uninterruptible power supply, or anything else that's battery powered, that's electronic, that too could be a source. And even though you removed PG&E's power, many devices may still be on, and some of them are noisemakers. There was a guy who had a battery powered remote operated doorbell I just read recently, and by golly, that thing was really noisy. So go figure. Anyway, you need to turn things off, and then hopefully you can find what the source is. Now, if you have a friendly neighbor, and it's good to be friends with your neighbors, believe me, when it comes to solving noise problems, your neighbor could do the same thing. So say the noise isn't in your house. Now, how are you going to find it? Well, this is where radio direction finding really comes into play. Now, all bands can be useful. We can start down the medium frequencies. That's the good old AM broadcast band, all through the HF bands, on up into VHF. Now, if you spend all your time on the repeaters and stuff like that, FM, VHF, things like that, you're a little more immune to a lot of interference. FM, for one thing, is most of this noise tends to be amplitude in nature, so FM is fairly resistant. But once in a while, you find noise sources that get all the way up into even 430 megahertz and so forth. So so not everybody gets away free on this. So one thing you prefer, at least, is a directional antenna, and even the little loopstick antenna that's built into an AM radio, that is directional. It'll have a null off one end of it, and that can help if the signal is audible on the AM broadcast bands. A Yagi, a VHF Yagi, is extremely good. If the noise goes all the way up to, say, 2 meters, you can take a little 2 or 3 element portable handheld Yagi. The kind that are made out of tape measures are kind of good for this. They're very light and flexible. And that can really pinpoint noise, for instance, on a power pole. On the HF bands, a portable handheld loop, like the one I held up before the meeting, is very good. And if you finally get into an area, say you're around, maybe it's your own radio equipment, and you know there's something noisy there, then what I use is a thing called, it's actually a magnetic field probe, or a sniffer. And this is just a couple little arbitrary little turns of wire on the end of a piece of coax plugged into a receiver. And you can hold this near various objects, and all of a sudden you'll find one that's really hot, that's really buzzing away. So that helps really pinpoint exactly, say, which cable the noise is traveling on, or which little device is generating the noise. So it's really a good thing. I think everybody should have one of these. They're so easy to make. And this, the description, this is on my webpage, and it's on the digital files that are associated with the ARRL antenna handbook, the current edition. It's a very simple thing to make, a couple turns of wire and a variable capacitor, a good old 365 picofarad AM radio variable cap. You can get those on eBay and Amazon and things like that. And that's pretty much it for the parts list. A little loop of coax, and the article shows you how to make it. And that can plug into any receiver. A little portable shortwave receiver is recommended. This particular one works from about 3 to 24 megahertz on this particular antenna. So that covers most of the HF bands, and it is quite directional. You get a null looking through the loop. And then when you turn it 90 degrees, you'll hear a peak. So that way you walk around with this holding up like a lollipop, and you rotate the antenna as you walk around, and you kind of triangulate in on the source of noise. So the radios, the typical little portable shortwave radio, these little Texans are very popular. I got a used Radio Shack receiver off eBay, a little cheap one. As long as it has an external antenna jack, just use it like a little 1/8" plug in there, and use your direction finding antenna. On the AM bands, it would have a loop stick in it that's also directional. Some handy talkies cover the HF bands. My D74, I tried it out, and I didn't think the sensitivity was very good in the HF bands compared to my little Radio Shack shortwave receiver, but it may be good enough. It's worth a try. Most important, you want to put it in AM mode or SSB if that's all you have, because again, all the noise tends to be amplitude in nature. If you have it on FM, it'll tend to reject most of the noise. So you really want AM to hear things buzzing, popping, and snapping when you walk around with a radio like this. So again, normally I would do a demonstration. So I have a noise source. We can turn it on and off, and I walk around with a direction finding antenna, try to locate it, and then we try to mitigate the source. So assuming you found the source, you found some widgets, objects, or something that's making noise, what do you do about this? Well, there's quite a few things you can do. First thing you want to do, if you can, is just simply remove the device or turn it off. For instance, I have some noisy fluorescent light ballasts in my shop, so I just don't turn those on when I'm operating. So if it's my equipment, I can just turn it off. Or maybe you have those new LED lights in the counter in the kitchen, and maybe again they're noisy, but you can just turn them off. Maybe you can replace the device with something less noisy. A good example is I have something that needs runs on 12 volts DC, and it comes with a wall wart. Well, that's a switching supply, it's noisy. Well, instead, I'm just going to run it off my nice clean 12 volt station supply bus and get rid of that. Or maybe you can find another power supply that's less noisy, or maybe it's a noisy LED light. Maybe you could find one that's quieter. Another thing to do is apply chokes. We're going to talk a lot about that. Common mode chokes. There's various kinds of filters and things that prevent the noise from being radiated. And a certain amount of shielding can also help. And finally, you can make your station more resistant to interference, for instance, by using a noise blanker. So we're going to talk about all these things. So the first thing you need to understand is how the noise is actually coupled. So here's a little basic electromagnetics here. So you have, say, a noise generator in a box or something like that, and it's connected to some wires. It could be any kind of wire. It could be coax, it could be twisted pair, it could be the power cord, it could be any kind of wires. So what happens is you have a normal signal. That's what we call a normal mode or differential signal. That's where one conductor is plus, the other is minus, or hot and neutral, whatever you want to call it. The current goes in one conductor and out the other, flowing in a circuit. It's going into the device, back out again. That's the normal signal that we don't want to tamper with. But then there's another one called common mode. And common mode is an interesting one. This is where the polarity effectively is the same on both conductors, and the current is flowing in the same polarity down all the conductors together. It also flows on the outside of coaxial cable shields. And whenever you have current, a changing current flowing on a wire, that generates electromagnetic radiations. How antennas work. We have a current wobbling back and forth on the wire at some frequency, and that will radiate. And likewise, if you have a magnetic field that's changing, that cuts across the wires, that will generate a current into the wire. So this solves both problems here, or just at least it covers both problems. The noise generator pumps this current out and it radiates. Or if this is my receiver over here in the box, the noise magnetic field cuts across the cables coming into my receiver, and that's a path of ingress for noise. So the more current you have, the louder the signal. The longer the wire, the better the antenna. So if you can reduce the current or shorten this antenna, that's going to tend to reduce the coupling of this common mode noise into your receiver or out of a noise generator. So what we use is a thing called a common mode choke. And a choke is, that's a term for a kind of an inductor. It may also be a very lossy inductor, so it turns electrical current into heat. So what we want to do is insert a high impedance in series with all the conductors. This does not affect the normal mode signals that are going in and out, but it does stop the common mode current. So if we have less current, that means less intense radiation. You put the choke close to the device, that means you've shortened the antenna. Another thing you can do is if you twist all the wires. It's always good to have twisted pairs. Ethernet cables are a good example of twisted pairs. And when you twist them, that helps reduce a lot of the magnetic field that otherwise helps to radiate noise or allow noise to couple back in. So what's a common mode choke look like? Well, they're normally made of ferrite. And ferrite, these are metals related to iron and nickel and things like that. These are magnetic materials. They're normally divided into powders and things like that. And they can be optimized for various frequency ranges. So not all ferrites are created equal. There's some mixes that are better than others. They come in a lot of different forms. A common one you'll see is a clamp-on, or looks like this. And you'll see these on all kinds of cables. Maybe you have a cable going to your monitor. It looks like a snake that swallowed a mouse. That little lump there is a chunk of ferrite, and that's used to prevent primarily VHF and UHF. A wire running through a clamp-on like this provides a modest level of impedance. It increases the frequency. This is mostly effective for VHF and UHF. Then there's larger clamp-ons. These get up to a bore of about 1 inch, and you can put a number of turns of wire through there, and the impedance goes up as the number of turns squared. So adding extra turns drastically increases this choking impedance, which is a good thing. Toroids are very common. That's a donut. Here's a small one. Here's a common 2.4 incher. And you wind a number of turns around this and you achieve a pretty high impedance. These are very good also for use on antennas. Here's some RG400. It's a Teflon high power coax wound around a 2.4 inch core. This is a very, very good high power choke for use on almost any antenna system. And there's a lot of information. I'll keep referring to this, k9yc.com. His publications are outstanding. He is absolutely the god of chokes these days. He completely rewrote a lot of the theory and practice of chokes recently. And his work is also in that grounding and bonding book as well. So our arch-nemesis, wall-warts and other switching type AC adapters. So if you can place them with linear power supplies. Sometimes you find them on eBay. They're hard to find these days. Or run things off your station's 12 volt DC if you can. If you're buying something new, see if it's DC powered. Hopefully it's 12 volts. Then you can avoid using the wall-wart. You can apply common mode chokes to it. Here's a case of a familiar looking adapter, and this single choke has both the line cord and the DC cord going through it. So one choke is actually doing double duty. Another thing I've done is build up AC line filters, and we'll show the details on this later. This is a bit of a project to make these, but this is a case where it actually has a commercial electromagnetic interference filter built into this outlet box, and there's an additional common mode choke on the power line. And so you can plug a noisy adapter into here, and that noise energy will then be stopped partially by the filter and then finally by this choke here. So this is what I call a wall-wart island. We've had to use this at a couple of stations where you just can't get rid of the wall-warts for whatever reason. So every LED light contains a switching power supply, except if you buy the ones that are meant for automotive use. Some of those are just plain, a bunch of series parallel LEDs, and they can run directly on DC. And some of them are really bad for RFI. This is, they're making millions and millions of these being installed every day. So what I found is that fixtures are the worst. So we buy a fixture, maybe it's in the form of a can that mounts in the ceiling, or maybe it's something that hangs on the wall. You just, you sort of plug it in. It's got a power supply in it and some number of LEDs. And I have yet to find a fixture that wasn't offensive as far as RFI is concerned. And they're fairly difficult to mitigate, especially like a can type fixture mounted in the ceiling. It's hard to get to, and it's hard to install a choke up in there. So if you're considering buying LED light fixtures, what I recommend is you buy one, test it, wave it around, near your antenna, tune around, see if you can hear the thing. If it's obviously there, you probably don't want to install many of them. Now, the good news is the screw-in light bulbs tend to be very quiet. On my website, I actually do characterizations of lighting devices, power supplies, all kinds of different things. I name names, I show model numbers, I'll tell you exactly which things are noisy and quiet, and especially the ones made by GE and Fite. This is all the various kinds of screw-in light bulbs. Those are very quiet, and you really won't have much trouble with those. Similarly, you'll find if you buy, for instance, a laptop charger from Apple or Dell, but Apple especially, they're exceptionally quiet. So if you want to run something like that is USB powered, you can get for like $10 on eBay, you can get an Apple charger that's good for like 12 or 15 watts. It's got a USB jack on it, and you can power anything you want, gives you 5 volts, and it's extremely clean. So clean switching power supplies do exist, but they normally come from name brand kind of companies, not the generic unknown Chinese ones with the phony FCC stickers. So if you go mobile and you have an inverter, you need 120 volts off your 12-volt battery. Well, the bad news is we haven't found any really clean inverters out there. So this is what K9YC went through to fix his little 120 volt 1 amp inverter. Choke, 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 choke on both sides of the line. That finally calmed it down enough that it didn't interfere with his mobile HF equipment. So these kinds of devices, be very suspicious when you buy, especially a high power switching device, be very suspicious that it's going to be a noisemaker. Uninterruptible power supplies, UPSs, some are good, some aren't so good. The world is pretty well established that the little ones from CyberPower, 1500 VA, these models are proven quiet. They're very good. They don't have a long run time. Running at full load, it's a matter of minutes, but it'll run a desktop computer, say running 50 watts or so, might run it for an hour or something like that. Those are very quiet. They're cheap, 250, 300 bucks, somewhere around there. Very good design. On the other hand, up my remote site, there's not one but two gigantic and very expensive trip-light UPSs. And this is one of the chokes we had to install. This is about 100 bucks worth of choke here. Gigantic ferrite rings and number 4 cable and 75 amp power poles and all that stuff on the battery, the external batteries to this thing. This is a noisy SOB, and it's a classic case of an industrial type UPS that we had no control over, but that's what got installed up there, and it's incredibly noisy. So, I mean, there's a write-up on my website about what it took to mitigate that thing. So again, it's a high power device with a switching supply in it. It's going to generate some amount of noise. But once in a while you find a company like CyberPower that took care to do the correct filtering inside, and it's very quiet. Another thing you'd never expect is a defective power strip. Now this is a good one. Well, first of all, a lot of them are just complete crap. The little plastic ones, they weigh almost nothing. You plug something into it and the plug just about falls out of it. Those are just plain unsafe. You have poor electrical connection. They're likely to heat up and catch fire. But what goes on inside is many of them contain these active components, the surge suppressor types. For instance, a metal oxide varistor, MOV, that's the thing that's used to clip off high voltage transients. Those are devices that are effectively born to fail, as each time they clip a transient, it actually damages them. And eventually their breakdown voltage gets lower and lower. What I found is that in the process of doing the clipping, they actually generate their own noise. Also, a lot of these surge suppressor things contain a number of active components, so that you'll find transistors and diodes and LEDs and all kinds of other stuff in there to indicate that a transient has occurred. Well, it turns out that those in themselves are generating noise. So here I have a cheap one made by APC. It came with an UPS, and it was the biggest noise maker in the shack. You just plug this with nothing plugged into it. Just plug it in the wall and it generates noise. We also find the intermod causes intermodulation at a multi-multi station where you have multiple transmitters on. So what I recommend is you go find something like the ones from Weber. Look at this thing. It's an all metal enclosure. It has nice, big, robust, commercial type outlets. It has a switch and a circuit breaker, nothing else. That's an excellent device. They cost a little bit more, but it's reliable and it's safe, and it will not generate any noise. Ethernet cables will radiate. They're not too bad. They're very well designed cables. What you find is that regular 10100 Ethernet is rather worse than gigabit. And there's some very common birdies that you'll find. For instance, if you get on 20 meters and tune around 14030, just about everyone on the planet will find some little ringing birdies around that frequency, and that's from 10100 Ethernet. They usually aren't too loud, but you can detect them. And the solution to that generally is to apply chokes at near each end of very long cables. If you have a 3-foot cable, that probably isn't going to be the problem. But if you have a 50 or 100-foot cable running, through the house or something like that, then a choke of this type is recommended, and that will take care of that kind of problem, as well as a lot of noise that comes from the devices that are plugged into the Ethernet cables. This is a case where, for instance, your cable modem has a wall wart to power it. Say the wall wart is noisy. What happens? The noise from the wall wart gets to the cable box, goes from the cable box down the Ethernet cable. The Ethernet cable now is a nice long antenna, maybe throughout your entire house. So by applying this choke right next to the cable box, you can then stop all the noise generated locally by that box from getting out. And that's, so my little box, when we're doing, running some DSL equipment, it has a choke like this on every single cable exiting that box. Ethernet cables, wall-wart, and the upstream foam cable. They all have a choke like this connected to it in order to make the thing completely quiet. Also, that prevents my transmitter from clobbering the DSL. So it works both ways. Plasma TV, can't fix it. The only solution is a bullet through the screen. Offer to buy your neighbor a new one. Thankfully, they're kind of falling out of favor. They radiate directly from the screen, and they cannot be fixed. Failing electrical equipment, these are usually pretty easy to track and fix. Fluorescent lamps, if the bulb is going out, that'll buzz away pretty good, but then you can see it flickering, and that's an easy fix. Flickering street lights the same way. One thing is the modern switching ballasts. Some of those are pretty noisy in fluorescent lamps. One thing is that there's a FCC Part 15 Class A versus B. Class B is for consumer stuff. If you look at any electronic device, you'll see a sticker on it, the FCC sticker, and it'll say it's certified for FCC. Part 15 Class B, consumer. But there's also Class A, which is industrial, and that's a much looser standard. And devices that are Class A are much more likely to cause interference in a domestic setting. So if you're buying, we'll say industrial or major heavy electrical equipment, if you can find a Class B certification rather than Class A, that would be preferred. All kinds of equipment fails. My neighbor's AC, air conditioner compressor, was making noise. Every time the thing came on, it made a big racket. And I walked over to his house with my with my direction finding antenna and the radio buzzing away. I said, "Turn off your air conditioner." He goes, turns it off, and it goes silent. I said, "That's your AC compressor about to fail. So either it's going to go out or it's just going to stop and catch fire. So I'd recommend you get it fixed so that that way you can pose this as a safety problem. So if you find noise at your neighbor's house, that's a very good tactic. You tell them, "Oh, I hear this noise. I've detected it with my radio equipment. It may be the indication of an electrical problem. And an electrical problem can be a big safety or fire hazard. So you might want to look into this, and I'm willing to help you solve this problem." So that's a really good way to build goodwill with your neighbor, saying that you're helping them solve what could become a very bad problem. In this case, I kept him from having his air conditioner fail. They were able to fix it preemptively. And that was the capacitor all buckled and pushing itself open. Solar. Well, the solar equipment it's variable. Some of the systems are okay. It depends on the specific installation and exactly what equipment they've installed. There's a QST article from April of 2016, and it points directly to Solar Edge and their panel optimizers, which are individual switching power supplies that are installed in every panel. These are an upsell, basically. They don't really increase efficiency very much, but they do increase the cost of the system, and they love to sell you these things. So instead of just having one big inverter down on the side of the house, you still have that one, but now you have many little inverters on every single panel. And either they can generate broadband noise, but in the case of Solar Edge, they actually generate noise over 200 kilohertz because of their telemetry, their control system. So the companies are, especially Solar Edge, actually they're willing to fix these problems, and you have to get on them. So you have to work with your neighbor, work with the installer, work with the manufacturer, and get them to use their best installation practices to reduce the noise. So, I mean, I can guarantee every system is going to generate some noise. Some are worse than others. Like the gear from Enphase, that's very good. It comes from Europe. Enphase is very, very good equipment. It's very low noise. A lot of big stations have that on their property, have no problem with it. And especially the ones that do not have the panel optimizers tend to be rather quiet. Power lines, back in the old days, this was basically the only source of RFI we had was, buzzing power lines. So the procedure in general is to try to locate the specific pole, which can be difficult. If you hear something crackling on a pole, that's a giveaway. But typically, you wander around with a VHF Yagi and try to pinpoint the noise on maybe on 2 meters, something like that. You write down the pole number, report it to PG&E. They have an online method that's probably a good place to start. And then you have to keep bugging them. Be sure you document everything. It can take quite a while. Then if they don't respond, the Public Utilities Commission has a way to lodge a complaint, and then they get back to PG&E and try to close the loop. ARRL is the next best thing. They have a hotline to FCC. ARRL actually is your best resource for really hard problems. The last time I went through one of these up my contest station, it took about 1.5 years, but eventually PG&E did respond. And in fact, the guy who came out to find the noise was a ham. So we gave him a tour of the shack, invited him to operate with us, and he was extremely helpful. He found cracked insulators. The most common thing, cracked insulators and bad lightning arresters. It's almost never a transformer. Their transformers are big, but when they fail, they normally simply explode. So the problem isn't necessarily what you think it is. It can be loose connections, cracked insulators, just all kinds of things that can happen. So if you hear the broadband crackling of power lines, and sometimes it'll stop when it rains, things like that, that can be a symptom. Underground systems are quiet, of course. So if you want to filter the AC lines, this is where I built my wall-wart island. It can be effective on certain kinds of AC line-borne noise, but it's a little more expensive to install, and it requires the fabrication of a safe that's an electrically safe 120 volt enclosure, and having the filter embedded inside the equipment. So these are commercial electromagnetic interference filters from a number of well-known international companies. These are designed to reduce especially normal mode, but also common mode noise to some extent. And this is a handy box. I put a fuse in it. I have this one's modestly rated like 5 amps. And all these outlets are filtered by this filter. And then what's not shown here is out on the AC line cord, there's an additional common mode choke. And this is a very effective filter unit, but as you can see, it does require some fabrication, and there are no commercial products available that do this. So the next thing you can do is reduce your station susceptibility to receive noise. So we'll go through some of these things in a little more detail. Common mode chokes on transmission lines, that is your coax going up the antennas, that prevents various kinds of radiated noise from getting to your receiver. Low noise receiving antennas are another way. Whatever antenna you may have, to add an additional receiving antenna can be quite useful. Typically, we find that horizontal polarization is somewhat better than vertical polarization for rejection of a lot of this local noise. And something as simple as a low dipole can actually be a good and cheap receive antenna. Maybe not a good transmit antenna, but actually can be fairly good for receiving in the face of a high noise level. And finally, use your rig's noise blanker and noise reduction features. Some of these are very sophisticated in modern radios. They're based on digital signal processing, and many of them have adjustments, and you have to sort of tune these NBNR features to reject your particular noise problem. But it can make a big difference to those of us that have high noise floors. So these common mode chokes can benefit nearly any antenna. They can be optimized, or should be optimized, for the bands of interest. So what's happening is noise is picked up on the outside of the coax shield. So whether you know it or not, your coax actually has 3 conductors. It has a center conductor and has the inside of the shield. That's where the power is normally transferred. And then there's the outside of the shield. And the reason the inside and the outside are not connected, even though they're all made of one piece of metal, is called skin effect. And skin effect is where high frequencies tend to travel just on the very thin surface of a conductor. So the RF power that you're transmitting receiving on the inside is confined to the inner surface of the shield, whereas noise that gets picked up from external radiation can ride on the outside of the coax. Well, the shield at coax, where does it go? It goes up to one side of your antenna. Once it hits that one side of your antenna, then it goes down the inside of your coax to your receiver. So if you put a choke at the antenna feed point, hanging up in the air, that can be very effective at reducing that kind of noise pickup. These can be optimized, and this particular article on what K9YC has written gives you the background on this, and it even has a cookbook on exactly how many turns of what kind of coax to use on what kind of core to get the best results. But any choke is better than no choke. Here's another option, is a low noise receiving loop. This is what I use. Mine's made by Wellbrook over in the UK. These are kind of neat. These are broadband antennas. They cover all the HF bands, no tuning required on these. And you orient it to null out your local QRM. And the reason I bought this was to get rid of my neighbor's plasma TV. So you turn this thing until you're looking through the loop. You point that, right at the source to null it out. And I actually placed this antenna as close as I could to my fence, literally as close as I could to his TV. And while listening to the noise on my receiver, I turned this until it nulled out his plasma TV. And it worked pretty well. Now this rejection only works in the near field, which is typically certainly less than 1 wavelength and preferably less than a half wavelength. So that means if you're on, say, 20 meters, you probably want to be within, say, 30 feet or something of the noise source, because beyond that, it just kind of turns into a dipole and doesn't really reject much. But nearby noise sources, it can be very effective. Resonant loops, some people use resonant loops like an Alex loop or all kinds of different tunable loops that can also be used as transmitters. And those are also very good in terms of reducing local QRM. Note that I have a common mode choke right here on the feed line so that the noise on the feed line doesn't get onto my low noise antenna. So here's one little myth I just want to go over. I need a better RF ground to reduce my noise. Well, sorry, no. The fact is there really is no such thing as an RF ground outside of the scope of, say, a circuit board or something like that. And the reason is we have this thing called wavelength. And you might remember little rules, a quarter wave. If you get to a quarter wavelength, a short turns into an open turns into a short. So you get very far from something and you're no longer connected to it when it comes to radio frequencies. There's also inductance. The self-inductance of any conductor raises its effective impedance. And finally, there's skin effect. All these things tend to raise the impedance. And realize that a connection to Earth almost never reduces the noise. What does the Earth like suck the noise away as if by magic? What's going on there? It makes no sense. And in fact, adding additional connections quite often will make the situation worse because the so-called ground wire acts as yet another noise antenna. You end up needing a choke on the ground wire. So just making an additional RF ground connection is extremely unlikely to do anything to noise except if it turns into some magic lucky counterpoise or something. More likely it's going to make it worse. But what is important is that a connection to earth ground is very important for lightning protection. Read the grounding and bonding book. It will explain all this in great detail, exactly why this is true. Now, we don't have a lot of lightning here in California, but that really is the basis for this. Also, what I'm talking about here has nothing to do with radial systems that are applied to vertical antennas. Radial counterpoise is a completely different issue, has nothing to do with this. So what about the FCC? Well, the FCC grants you legal rights and responsibilities. So here's the letter of the law, just in case you're interested. This is what the law says. So, okay, a device that causes harmful interference. And by the way, the term harmful interference means where a licensed radio service can no longer operate. The interference is so bad that it's disabling. And harmful interference can only be legally determined by the FCC, by an FCC field inspector. But very high levels of noise, harmful interference, any device that causes that is the responsibility of the operator, the owner. They are the ones that have to fix it. You aren't responsible. The manufacturer isn't responsible. The city isn't responsible. No, it's the owner. It's the operator. It's your neighbor with the noisy whatever it is. They are legally responsible for fixing the problem. Likewise, devices that cannot accept interference from a licensed, legally operated service is handled the same way. That is, legally, If your properly operated clean transmitter is getting into your neighbor's stereo, it is legally their problem to fix it. However, it's a really bad thing just to, raise your middle finger at your neighbor and say, I'm not going to fix it and I don't care. That's probably the worst thing you could do. It's bad for amateur radio. It's bad for your relationship with the neighbors. And the FCC says, no, you're not doing the right thing. It says, we want you to fix the problem locally. So as a goodwill gesture, you need to help. You need to fix it. Whether they're causing the problem or you're getting their stereo, whatever it is, you need to work to fix this problem. Be nice to your neighbors. If you're not nice to them, I guarantee nothing will be fixed. If the problem gets very difficult, call the ARRL. The guy there, I love the call signs. Ed Hare, W1 RFI. How cool a call sign is that for radio frequency interference? W1 RFI. He runs the ARRL lab. And he and a couple other guys, they're very, very good consultants. And you can call them up, and it's best to just call them on the phone and explain what's going on. And they'll point you to a number of resources, their website, obviously this RFI book. Have you read this? Have you done this? What are you doing? What are you not doing? And they can walk you through the process, regardless of how complicated it may be. Also, if things get really serious, the ARRL is the means by which you would contact the FCC if you want to elevate this to a federal level. You don't want to do that. I've been there, done that. It's highly unpleasant, takes forever, and it may not resolve things. It just creates more bad blood. So again, the law is on your side, but practical matters may intervene. So you do the best you can to fix these problems. And this is another reason that every club should have somebody who's kind of appointed as like the RFI expert, someone who's kind of involved with this stuff and knows the ins and outs, has the book, maybe has an antenna, knows who to call and things like that. It's good to have someone in your club to help with these things because everyone is going to have these kinds of problems at some level. So a list of references, the books, the K9YC website, my website. Again, these slides will be available so you don't have to write all this down. Oh, by the way, one of the things I do when I'm on Zoom is I have a screenshot utility open, like on Windows, it's a snipping tool, or on the Mac, it's just a keyboard combination. And somebody puts something up like, oh, that's really good. You like the picture, you like the information. And I grab a screenshot and like save it to a Word document or something like that. So you can, instantly screenshot it I'm on Zoom so much, I might as well make the most of it. I also have some references here. These are part numbers and sources for some of our favorite ferrite materials for making chokes. And these are some good sources. A lot of the good industrial sources of components are recommended. The prices are good. Avoid highly advertised Palomar engineering. It's way overpriced. DX engineering is even worse. Amidon also is another one. For the same thing, they'll charge anywhere from 2 to 4 times the price that you should pay for these components. So these chokes are actually very affordable. The classic 2.4-inch ferrite is roughly $6 right now. If you buy a commercial ballon or a commercial choke of some kind, it'll be $50, $70, $80. And really what it comes down to, it's this $6 thing with some wire wound around it. So you too can build your own high quality chokes and ballons with nothing more than a $6 chunk of ferrite. So the epilogue here, and there's a nice report on this. Some people saw my talk at Pacificon. I gave this talk. My neighbor installed a bunch of LED light fixtures, and I went all the way up to the FCC. I always wanted to do that. I don't know why. I'm a glutton for punishment. And we actually did make an attempt at fixing it, but the fixtures say are very difficult to mitigate, and it was a 20 dB solution to a 40 dB problem. So, and then my neighbor moved in, a new neighbor moved in, and they installed, well, guess what? Solar edge with panel optimizers. So it got even more noisy. So I kind of abandoned the home station, and I have this. So I have a remote station up on top of a hill, which is absolutely fantastic, thanks to a partner of mine I work with. So, but even this has other noise. You can see these other dishes there. That's commercial microwave gear. And there's other power supplies. There's an adjacent little tower you can see way off to the left. There's all kinds of noisemakers up there. And I estimate I have over $1,000 in ferrite just at this station trying to mitigate these other noise sources. I can't get rid of them all. They're in all bands. So, no place is perfect. I do everything I can to fix it though. So with that, I will stop my screen sharing there, and we'll open this up to questions. People may have to unmute themselves to talk.
Yeah, this is Jim, and I was going to ask. I had looked into getting solar for my house, and it was one of the distributed systems. And a neighbor put one in 4 or 5 houses down, and it generated an ungodly amount of noise. But the interesting thing was they had filtered on the ham bands, believe it or not, on 40 meters and 20 meters of what I operate on. The noise was substantially reduced, but outside of those bands, it was pretty goddamn awful.
Wow.
And so I was going to put it on my house, and I decided that was a bad idea. Do people actually operate with solar on their houses?
Oh, absolutely. There's even some big contest stations like K1TTT with a big solar array right at the base of one of his towers. His equipment is N phase, and it's just one big inverter. It does not have these panel optimizers, and that one's very quiet. Up at N6RO, we have a big solar system hanging up there. Again, it's just a bunch of panels and a single inverter, and it's quiet. It's not a problem at all. I mean, 3 feet from it with my little noise antenna, I finally start to hear the faintest little buzz. So, and there's guys with solar panels all over the roof, and their wire antennas just about touching the panels, and they don't have a problem. And the reason is it has a quiet inverter, just one, down on the side of the house. So it can be done, but not all solar equipment is created equal, and sometimes you don't know until it's too late.
Gary?
Yeah.
Thanks so much for coming down from all this way from Livermore.
It's a long trip, yeah.
Long trip. I wish I had talked to you about a year ago about Palomar. It's not just their equipment that's so expensive, it's the shipping.
Oh.
They'll rake you. So anyway, thanks for that advice.
Yep.
So Garrett, I do have a question as well. I have a hybrid car, and I've heard that putting a mobile station in hybrid cars causes all kinds of problems because of the charging circuits for the high power batteries. Do you have any experience with that?
I don't. I've only just heard a couple little, anecdotal things about the hybrid and the EVs. Well, example is if you buy a Tesla, you'll find it does not have a radio that covers the AM band. I wonder why that is. So, I mean, they have an almost insurmountable problem in anything that's a hybrid electric vehicle. You have to consider their switching circuits. They're commutating, hundreds of amps. These conductors, and they do what they can to keep the thing from being a horrible radiator. They too have to pass at least FCC Part 15. They can only radiate so much crap before it's illegal to sell their product in the United States. So they do what they can, but having your radio with an antenna, right there in and on the vehicle, good luck. I mean, go try it. I would definitely, walk around the car with something portable or temporary just to find out what it does, when it's on the road.
Yeah, my experience so far has been that if I just have a temporary antenna on the roof and don't have the car on, it operates just fine. But I haven't tried it with actually while driving, so I don't know what experience other than what I read was don't do it.
Yeah, good luck.
Gary, I've got a question. For years ago, I purchased the MFJ 1026 noise canceller. Are you familiar with that? And the ANC4 is another equivalent. I never get the feeling that it's actually doing me any good, and I'm figuring that there's just something that I don't know about how to twist them knobs, and I'm wondering if you had some ideas as to where I could go to figure that out.
Yeah, the adaptive noise cancelers, I was thinking of, adding that to this talk, actually. It's a case where your mileage may vary tremendously. So the way these noise cancelers work is that your regular signal comes in one port, and then you have another, what's called a noise sensing antenna that comes in another port. And if you imagine that this noise sensing antenna ideally is rather different from your main receiving antennas. Maybe if your main receiving antenna is horizontally polarized, your noise sensing antenna may be best if it's vertical. And I got one to work reasonably well against some of the noise from my neighbors. And the way it works is the noise sensing antenna is hopefully receiving primarily just the noise and not the signals that you're interested in. So now what you have is signals that you have noise present on both antennas. And with a careful adjustment of amplitude and phase, you can subtract one from the other. So you have a knob to adjust amplitude, you have a knob to adjust phase, and you can very carefully null out the noise. And when it works, it's almost magic. I mean, it's just incredible what it can do. If the two antennas are receiving exactly the same signal as well, the problem is you'll then null out the signal along with the noise. So, and people get results all over the map. I mean, from, Ron, you're not having too much luck. I can appreciate that. I had some luck with it. And what I did is I placed the receive antenna, which is just a little vertical. I placed it again on the fence right next to the neighbor's house because I knew that's where the noise was coming from. And it was a relatively small vertical antenna. And meanwhile, I'm receiving on a dipole for my, doing my transceiving on a dipole. So the little noise antenna was placed sort of as close as I get to the noise source. And then I was able to get a fair amount of nulling on some bands at least. It started to work. And the other problem with it is the thing is very tweaky. This amplitude and phase, it's like you're on a knife edge all the time. And every time you tune across the band, let alone change bands, you have to readjust the thing. You're sitting there tweaking. Here's the amplitude and the phase. You're adjusting and nulling and stuff. And if you're just sort of like doing some DXing or whatever, I really want to get that rare one. You sit there and fiddle and optimize it. It's okay. But like if you're running a contest and you're trying to search and pounce up the band, it's hopeless. I mean, you have to adjust it every 5 kilohertz or something like that. So so it's kind of a difficult device to use. There's several on the market, and all you could do is try and experiment with it and find out how it works for your particular problem.
By the way, a side question. I run here in Concord a Yaesu FT1000MP. It's a 20-year-old radio. It's got an NB1 and an NB2, the typical both noise blankers. I find in a way that it doesn't do much of a job, and if you turn the knob up, eventually it distorts. And it's supposed to work only for the main receiver. But on the sub receiver, when I turn that noise blanker on, boom, noise is gone.
Huh.
How is that happening? And nobody can seem to answer why the noise blanker that's supposed to only work in receiver A actually works in receiver B. So I end up receiving on receiver B because it's got a wider filter, but it has less noise.
Yeah, I don't know, Ron. Haven't used a 1000 myself, so you've created your very own miracle. Be happy if it works.
Well, it is a miracle, and I am happy that it works. By the way, I'm from Livermore. I went to Livermore High School, so I assume that you went to high school there as well.
Well, actually, I'm from Illinois, but I hear you in all the contests. You're always out there at NX6T and stuff like that. So.
Yep, I'm running WQ6X this weekend from Ballborough.
Okay, good.
Thank you for this presentation. This has been very informative.
Yeah, you're welcome. Next.
Yeah, I enjoyed the presentation myself very much. In fact, I think I saw you at PacificCon 2 years ago. You did mention that we were going to have access to the slides for your presentation.
Right. If you look at it's just been posted in the chat. You click the little chat icon. It's up in the chat right now. Is the link there?
Okay.
Yeah, and I sent it to everybody to a couple of your guys. So anyway, yeah, it's on my website there. My RFI pages and this
Yep,
talk.
there it is. I just linked to it and boom, looks beautiful.
Yeah.
And then I'll also send out a copy and a follow-up email after this meeting to everyone as well. So don't worry about it.
Oh,
Yep.
great.
You're covered.
Does anyone else have any questions?
I'm just gonna follow up on that question that Ron had about the noise reducers. And I'm gonna talk a little bit about this next month as well, but yeah, what I have is it's the DX Engineering NCC-2, and I paired that with a vertical on one end of the property, and on the attached to the chimney on the house, I have a amplified loop receiving antenna. And yeah, it's not something you would want to use for contesting, as you got to have the time to tweak it. But it's when it works, it's like miraculous, but it doesn't always work.
Yeah.
And I'd just like to mention that we put solar panels on our roof in August, and I haven't noticed any difference at all.
That's good. What do you know? What manufacturer is it?
I don't recall. My wife took care of the whole thing. It was her idea, and she was in charge of that, and she's not here right now.
Okay. Yeah, it's always interesting to get at least some notes from the field about what's good and bad in solar. Just recent installations, and the companies are, especially like Solar Edge. We know they've been working to try to improve their equipment and especially improve the installation procedures. There's a bunch of things that the installers do incorrectly. The way they route the wires, it creates a gigantic magnetic loop among all the panels. That's a big problem. They're supposed to twist the conductors together. So, part of it's the manufacturer, part of it's the installers, but hopefully, solar is just, it's everywhere and going in fast and furious. So, hopefully it's not going to be, one more thing that's helping, kill amateur radio. But it's good to know, there are systems like that that are quiet.
If there are no further questions, actually, there is one question that was listed in the chat, but somehow missed. Donna Fong, she had asked, I think when you were talking about the wireless doorbells, do those doorbells cause noise when they're not being used as well? Since
Yeah, for some reason, it actually was the little receiver, not the doorbell itself. It was the little receiver, and that thing, it had, whatever powered it or something like that was the major noisemaker. The guy was surprised. He posted it to there's an RFI online kind of chat group, RFI reflector, and the guy, I got this weird noise. I don't know where it is and this kind of stuff. And he comes back sort of sheepishly. Oh, it's me. It's this new wireless doorbell of all things. So I don't know. I don't know the details, but the darndest things can creep up on you like that. So every time you buy a new electronic thing and plug it in, check your radio again, because you never know.
Well, when I just out of my experience, when I put up my vertical antenna outside by my garage, we have a small patio. I found when I was transmitting, I can't remember which frequency now, my garage door would open. And what it turned out to be was that it was a vertical antenna, ran just up on the other side of the wall from the wire that with the manual push button that opened the garage door, and it was generating the proper enough voltage in that wire to open it. So I put chokes on everything, and that solved that problem.
That's it. Yeah, well done. That's exactly what the chokes will do. The classic thing is the noise. Your transmitters coming through the speakers and the stereo, is you apply the chokes to the to the speaker cables, that kind of stuff. And it's a very simple fix, and it doesn't have to be expensive. So a little ferrite goes a long way. Good for you.
I wanted to just quickly ask who, I didn't catch who had said they had installed solar on their house and didn't have a problem. Who was the manufacturer?
Um,
Here we go.
I'll have to check. I don't remember. It's either Sunwork or Sunworks, and there's two different companies. And if you give me your email address or phone number, I can call you a little while.
Oh, okay. It's jtw@pobox.com.
PObox.com?
Yeah, POBOX.
Okay.
What is that red phone and bell behind you?
Oh, that's an antique telephone that that I bought, and it actually, when we had a landline, it actually worked. It's got the dial, just like we used to use in the old days, and it's one of about 4 antique telephones I have around the house.
Nice.
I thought it was a hotline, maybe to somewhere.
Definitely cool.
That's the line that the president calls him on when he needs to
Yeah,
make
there
an
you
important
go.
decision.
There you go.
Well, when we disconnected from the landline, I also have some antique telephone cranks that generate electricity that makes the bells ring. And I went outside to the box and tried to get it to ring and see if I could do some interesting stuff. A friend of mine asked me if all of the telephones in the neighborhood were ringing, so I thought I better stop that.
Doug, when I was a kid, my dad brought home one of those that had the crank, and he actually converted. He put but you could open the front, and he put the dial phone inside, so he could just open it and use it.
That's great.
It worked, and but he left the little generator in there. And one of the fun things we used to do as a kid was to put our fingers on the contacts and crank it and see how long we could hold on to it.
Apparently people used to scrap those magnetos out of old telephones and then hook up a couple wires, throw them into a pond, crank it up, and then all the fish would get electrocuted and just float right up.
Oh my God.
Yeah, I remember hearing stories about that in the South, definitely. So the house that I bought in Maine has an old AT&T phone on the wall, dial phone, not quite as old as yours, but it has a similar, it's a wall phone, like the old wall phones you used to have. So it's kind of cool. I'm going to leave it there just for memorabilia. So.
Yeah.
If there's no further questions for Gary, is it all right if I give the club members your email if they want to reach out and get in touch with you?
Yeah, absolutely. I'm always happy to help where I can. Lord knows the ham radio is crippled by noise, so if I can help somebody get back on the air, glad to do so.
All right. Well, thank you very much. We appreciate your time and this awesome presentation that you did for the club. Is there any final business for this February meeting?
I can't think of anything.
Okay.
We do have net control signups and regular business stuff, right? We're gonna do the regular business.
I think we are set through March. We can do that for the March meeting.
Usually we do at least 2 months out. So we have one person for April. So we don't have anybody in April. So if we can do that and get that confirmed, that'd be good just so we have the people that we have here and see if anyone's interested.
Okay, hold on. Let me pull that up real quick then.
I have it handy. I have April 8th, the 22nd, and the 29th is open. April 15th is Dan, KG6YZF. I see Roger's raising his hand.
Yeah, I'll take the 8th.
Okay. And we're the 22nd and the 29th. Is anyone on this call available for either of those? If not, I'll reach out to the people that are not on this call today. And we can ask in the March meeting as well.
Is Donna still with us?
No, she left early, I guess.
Okay.
Also, Hank's not here and some other people, so I'll reach out to them as well. Doug, you usually do a couple. Are you available in April?
Let me check.
Yeah, I
April 22nd, 29th?
I would volunteer, but I'm going to be out of town for 2 months. So April and May.
Okay, fine.
June, I'm available.
Okay. I also have a question about BridgeCom. Has anyone ever used a BridgeCom repeater system? We're looking to replace the CERT repeater with a BridgeCom rack-mounted system, 2 meter, and new cans as well in the box on top of the hospital. Don't know if anyone's ever used their systems. BridgeCom.com, I think.
I think if you check with the group down who's based down in South Bay, I'm trying to remember what the name of Baynet, I think it is. They have a DMR repeater
Okay.
down there.
Okay.
And I think the guy who's really sort of the head guy there's George something or other. I can look him up for you.
Okay.
There's another one.
Oh, that's a nice phone. Yeah.
Okay, this is Doug. Yeah, I'm open on the whole month of April. I'm not going anywhere. I mean, who is?
Okay. We'll put you down for the 22nd for now.
Okay, got it.
Okay. All right. Thank you, sir. So that's it. Oh, also, CERT's going to be having a training class similar to what Paul Bailey Gates did for new ham operators. We're creating a class we have a lot of new people that have gotten their license. They just don't know how to use them yet or have radios. So we're going to talk about new radios, what's available, features to look for, basics on how to get on a net. We encourage everyone that's gotten a license recently to get some kind of radio and at least listen to our Thursday night nets so they know how to listen and how to talk. So we're going to be having a class similar to that very soon.
What's the date for that?
We don't have a date yet. We're still working on this semantic support and the paperwork. We're taking some of Paul Bailey Gates' notes. We didn't want to bother him at this point, but we talked to him 2 years ago about it, and then COVID hit. So we're looking to create our own class just so we don't have to get him involved. If we have any questions or if we run into a snag, we'll reach out to him as well.
Okay.
Okay, that's it for me.
Just a quick question. Roger, did you give a description of your speech for next month?
I thought I did.
Okay.
Did I send it to you?
No, you sent it over to me, Roger. It's your thing about the road to DXing.
Yeah.
Yeah.
Yeah, that's fine. Yeah.
So we got that to look forward to next month. If there's no other business,
I've got a quick question for Jim. Is that Juliet Tango Whiskey, PObox.com?
That's correct.
Okay, thanks.
Thank you, sir.
Thank you.
okay, motion to adjourn the February meeting.
Good meeting. Thanks,
Time
Ed.
to go play North American QSO Party Riddy. Get on the air and play Riddy.
All right, thank you, everybody.
Okay, thank you.
Thank you.
Thank you.
Thanks, Gary. Nice presentation.
Yeah, great presentation.
That was fantastic. Yeah.